After finishing up the footer and the utility preparation on the pad, I started taking apart the forms that we use for the footer and started rounding up supplies for the AIRCRETE. In this video, we'll be making the forms for the test batches of AIRCRETE. We'll also be putting together the foamer that we purchased, and we'll also give you a breakdown of all of the costs for the tools and equipment that are necessary to make AIRCRETE. Here I'm taking apart the forms that we use for the footers. We try to reuse as much of the material as we can, and so most of these boards, even though they've been used for concrete twice, still have some life left in them, so I'm going to take them apart and try to salvage as much as possible. One of the things we need for mixing AIRCRETE is a 55-gallon drum. We wanted to go with a steel drum just for the durability and also be able to modify it a little bit later on. We could not find any locally. There seems to be a shortage. And normally they would run, from $50 to $150, depending, but we couldn't find any. Thankfully, we had a friend who offered to give us his, and so we acquired one free of cost. The only thing is that he was using it to store stuff in, and he had drilled some holes for drainage in the bottom, so I had to go in and weld up those holes to seal those up. But other than that, it was a perfectly functional barrel, and we were happy to have it. Our next move with AIRCRETE is to create several test batches using different mixes, and we want to be as scientific as possible and test each of those batches and compare them to each other and actually have some kind of scientific type data. And so in order to do this, I needed test samples that we could do some destructive testing on, and I wanted them to be uniform in size, and so I'm creating some molds that we'll use for all of the test sample batches that we create. Each time we do a sample batch with a different mixture, I will capture some of that AIRCRETE in these molds, and we'll treat all these molds the same as far as keep them all wet for the same amount of time, let them cure for the same amount of time, and then we'll perform testing and compare the results. And so I would set about here to make some good molds. I decided to go ahead and just use some of those forms that I just got through taking apart and just kind of repurpose that wood. And so I had to do quite a bit of work to get it straight. And so here I'm using a planer to take the cupping out of the wood. And that involved using a planer, as you see here, and then I used a joiner to get the edges, and then I used a miter saw to get the ends true. With just a little bit of work, I was able to get all this lumber back to a good usable condition so I can make some really nice forms. I was really pleased with how it turned out. The forms went together well. They're good forms that should work out well for the testing. I'm making 2 sets of forms so that we'll be able to capture samples from 2 test batches at a time, and then they'll have to sit in the form for 24 hours before they can be removed. So I want 2 identical sets of forms, and each form will capture 3 samples. 2 samples will be 4 inches by 4.5 inches by 36 inches long, and I'll use those for some tensile strength testing. And then we have another sample from the end of the form there that you see that will be 9 by 9.5 inches by 4 inches thick, and that will be for impact testing that we'll perform as well. So here's me making, kind of assembling the 2 identical sets of forms. After the forms were completely assembled, I coated them in Thompson water seal to give them some water resistance. We'll also coat them with some cooking oil to help them release from the concrete. They will be mounted onto a flat board that has a piece of plastic over it. So once we're ready to release the forms, I'll just unscrew them from that base board, and they ought to come off well since there'll be a coat of plastic between the form and the base, and then hopefully they'll release pretty easily with that oil. We're excited to be able to finally put together our little dragon foamer. We ordered this from the nice folks in Hawaii, and there was a little bit of delay because they were having trouble acquiring some parts, but ordered it a long time ago and it came in, so finally getting to put it together and excited about that. It came nicely packaged in a box with some good instructions. They also had some video instructions that you can follow along as well. And it's pretty simple, wasn't too bad at all. It seemed like good quality parts and quality craftsmanship of the parts that they fabricated. It was kind of a fun little project here to follow those instructions and put it together. Ended up taking me, I messed around with it for probably an hour and a half or 2 hours. I think the guy in the video put it together in 15 minutes, so it took me a lot longer by the time I rounded up the tools and read the instructions several times and all that. But I actually saved, by ordering the kit, you save about $140, as compared to buying the same thing, assembled by them. So it was well worth my time to do it myself. And I also like, the experience of putting it together myself, and I get a feel for how it works, what all the parts are. And so I feel like it would be worth assembling it even if I didn't save money by doing it myself, just for the familiarity, with the product. If there's problems with it in the future, I have a pretty good understanding how it works and how I can acquire replacement parts and that kind of thing. So, and troubleshoot. Hopefully I won't have any trouble, but I feel like I have a pretty good understanding of it since I put it together myself. I did do a little research, before I ordered this, just on the cost of parts and how much it would cost to source all the individual parts myself, and didn't come up, it didn't look very appealing. It didn't seem like it was going to save me a lot of money to try to source all the parts myself. So it seemed like, to me, it was worthwhile to go ahead and buy the kit. Cost just a little bit, maybe more than I would have, spent sourcing all the parts myself, but I know they all fit, I know they all work together. Also, this company has been doing this for a good while, and they have experience with all the parts, and I know they work well. Here I am putting a little filter on the end. That was kind of tricky to get that in place. You have to push a little brass nail through the filter and through the tube, and I just use a kind of a clamp to do that, and it worked pretty well. The next kind of final part of the process here was to put in the wire. I guess it's kind of like a stainless steel scrubbing pad, but it's kind of the magic part of the foam making process. This is a really important part where you pack this in, because all your air and your soap and your water are going to go through this, and out the other side are going to come the bubbles. And so you put in a bunch of this stainless steel kind of scrubbing pad type material. You pack it all in good, and it's the action of the water and soap and air going through this that creates that dense foam mixture. After I got that all in and tucked in nicely, I just glued it together with regular PVC glue and kind of finished up the final assembly. Here's a quick cost breakdown of the supplies. We ordered a brand new, nice Makita air compressor. Quiet, I'm very excited about it. It was $259. The cement mixer was $84. The Little Dragon foamer was $359. The barrel we got for free, but it would normally be $50 to $150. Also, something that might be optional, but that we did purchase, is a water softener, sized for an RV, that was $225. We'll go into that more later and why we bought it. And then you just need kind of some of the incidentals, buckets, gloves, little things like that. That green cover you see there, that's all it is just a cover to protect the components, I guess, while you're out working on it. Overall, the assembly wasn't too bad. It's nothing terribly complicated. Everything that you need comes in the kit, except the tools to assemble, which, not too bad, just a few different wrenches. Like I said, some channel locks, a few little things like that, but nothing too crazy as far as tools. Another important piece of equipment for mixing AIRCRETE is your drill, and so I picked up one off of Amazon. I think it was around $85, and it's like a 12-speed. It has a slow start, which I like, so when you pull the trigger, it kind of slowly winds up speed, and so it looks like it's going to be a great little drill. The only thing I wish is that the auger part was a little bit longer. I think it'll work fine, but I think if I was to buy it again, I would try to find one that had a little bit longer rod on the auger. But this one looks great. Hopefully it'll work. While we're doing all this AIRCRETE testing and making all these sample batches, we needed something to do with the excess material that we're not actually using for testing purposes. And so a little project that we've had in the back of our mind for a long time is to build a little garden wall, kind of a half wall out of AIRCRETE, and then go up the rest with wire. And so we decided this was the perfect project to kind of get our feet wet with making AIRCRETE and also use the excess of the batches. So that was kind of the final step in order to get ready to actually start mixing AIRCRETE, was to form up this garden wall so that we had somewhere to put the excess. So started working on that here. I decided to go ahead and reuse some of the old forms from the footer. This is the third time they've been used, and the wood is pretty warped and crooked, but you know, with a little finagling, it turned out just fine. Just takes a little bit of extra work to make it, you know, kind of true and straight. But the first thing to do is just kind of, you know, mark it out and measure it out on the ground, and then to get it kind of flat with the shovel so that we had a pretty good flat space. And then I went along with the shovel and dug a little kind of 2 or 3 inch deep. There's about a 2 inch deep kind of trench, just get below ground level a little bit for the base of our AIRCRETE garden wall. And then I started building the form with kind of the reused materials. Used some of the bases and then some of the sidewalls, the sidewall wood, the OSB that was actually down in the trench and we had to work so hard to get out. I was able to reuse quite a bit of that. Kind of assemble those to make a garden wall that's 2 feet high and 5.5 inches thick. Once we get this 2 foot high section poured all the way around, we will of course have to do the normal thing where you kind of plaster both sides with some kind of a fabric mesh to give it that extra strength, so we'll do that. And also, before we pour, we're putting in T-posts into the ground, kind of up through the forms every 8 feet. And so those T-posts will be, you know, start off in the ground, they'll go up through the 2 foot wall and be, you know, encased in the wall. And then they'll also stick up 4 feet above that. And that'll be perfect for us to attach 4 foot of wire fencing on top of the 2 foot garden wall. So we'll end up with a fence that is 6 foot high total, but with a 2 foot tall concrete base, which we really like. We're hoping that'll keep out a lot of the rodents and small animals here that can be pretty vicious when you have a new garden in the spring. So we're just finishing up these forms and doing all the kind of the last minute preparations to get ready to do our first pour of AIRCRETE. We're really excited about it. We hope to do 2 pours of AIRCRETE tomorrow and take samples for testing from both of those. So really excited to actually get started mixing AIRCRETE.